In this video, I'm going to talk about properties of air. So what do we mean by air properties? Whenever we describe something, for example, a table, okay, how are we going to describe the table to another person? We will talk about maybe the materials, the texture, the color, the size, the dimension. So for air, when we want to describe the air to another person, how can we describe the properties of air? So over here, if you take a look, there are 7 of them. The most obvious one that come to our mind whenever we describe an air is temperature. But if you take a look over here, when we talk about temperature, there are 3 types of temperature. And another common properties that we often use to describe air properties, okay, is humidity. But if you look over here, there are actually 2 types of humidity. So what's the difference between these 2? And lastly, we will also talk about specific volume and specific enthalpy. Now, I will go through each and every one in detail. Dry bulb temperature. Dry bulb temperature is the common temperature that we have known. For example, a body temperature is 37 degrees Celsius, and an air-conditioned space is 24 degrees Celsius, 25 degrees Celsius. All these temperatures are what we call dry bulb temperature. And how do we measure that? We will use a standard thermometer or just a normal temperature sensor, RTD, to measure the temperature. So this temperature will change if we do heating or cooling to it. And to be more specific, it is sensible cooling. If you look over here, there is a word called sensible. Alright, so what does that mean? When for example, if you want to heat up the room, from 19 degrees Celsius to 25 degrees Celsius, sometimes you will get an electric heater and put it inside the room. So the electric heater, the sole purpose of the heater is to heat up the air temperature in the room. And it's not changing other properties. It's purely dry bulb temperature. So that's what we call sensible heating or cooling. The second temperature that you see over here is called wet bulb temperature. What is wet bulb temperature? Before I talk about that, let's look at this particular equipment, which is what we call a sling psychrometer. So on a sling psychrometer, there are 2 thermometers. They are the same, except one of them, the bulb area is covered up. It's covered up by a wetted wick. So what is a wetted wick? That means there is moisture on the bulb itself. So how do you use this device? You will hold on to this area, okay, you will hold on to the handle, and you start to swing this device round and round and round. Why are we doing that? Because when you are swinging the device, you are trying to induce evaporation on the water that is on the bulb. So when you swing, water will start to evaporate, and when it evaporates, it will remove heat from the bulb itself. So that is why wet bulb temperature will always be slightly lower than dry bulb temperature. So let's do a quick comparison. For example, dry bulb temperature, after you swing for 2 minutes, it reads off 28 degrees Celsius. Okay, so most probably your wet bulb temperature should be lower. For example, 25 degrees Celsius. Alright, so will there be a situation where the dry bulb is lower than a wet bulb? Okay, it's not possible. It's impossible. It just doesn't, it will violate the law of physics. Okay, the best it can get, it will be, these 2 temperature will be the same. Okay, maybe 28 degrees Celsius dry bulb and 28 degrees Celsius wet bulb. And when will that occur? Okay, that will occur when we take a step back. Okay, temperature of the wet bulb thermometer will not drop if there is no evaporation. When will there be no evaporation? So one of the more simple answer is because there's no more water on the bulb itself. But assuming there is water on the bulb itself, but there's no evaporation, what does that mean? It means that the air is already saturated with water. So water simply cannot evaporate anymore. So In another words, the air is already 100% in 100% humidity, which we will come to this term later. Alright, so and when the temperature difference is very big, that means between dry bulb and wet bulb, let's say the temperature difference is, instead of 28 and 25, is 28 and 18 degrees Celsius. What does that mean again? Okay, it just means that the air currently that you are measuring is very dry. It's very dry, the humidity is very low. That is why water evaporate very fast from the bulb. The water will evaporate very fast and it bring off, it will cool down the bulb by a large degree. The third temperature we are going to talk about is called dew point temperature. So have you ever wondered why whenever you take a can of soft drink, water will start to form on the surface of the soft drink? Alright, as we know, this process is called condensation. So the colder is the object, usually the more amount of water will form on the surface of the object. Alright, so why does that happen? Okay, it's because temperature has reached dew point and water will have to come out as condensate. So maybe let me use this as an example. Let's say the air temperature now is 28 degrees Celsius and the dew point of the air is around 20 degrees Celsius. However, the temperature of the soft drink is, let's say, 7 degrees Celsius. So what happens is the surface of the soft drink will start to cool down the air around it. So the air around it, temperature from 28, it will start to decrease from 28 to 27 to 26, all the way until it's 20 degrees Celsius when it reach the dew point. And if it continue to reduce in temperature, let's say from 20 degrees Celsius down to 19 or 18 degrees Celsius, water will have to form, will have to come out, because the air is not able to contain the water anymore. It has to come out as condensate, because the ability to hold water will drop whenever the dry bulb temperature reduces. Later when we talk about humidity, we will revisit this point again. Alright, so condensation will happen whenever warm air touches cold surface. Okay, you may have noticed, let's say you alight from an air-conditioned bus, okay, or from a vehicle that is very cold. During the early morning, usually maybe your spectacles or your mobile phone will get a bit of moisture. There will be a bit of condensation happening. Okay, why is that so? It's because early in the morning, the dry bulb temperature and the dew point temperature is actually quite close. Maybe they are just 2 degrees Celsius away from each other. So when it touches the cold surface of your spectacles or your mobile phone, it reaches dew point very fast, or even below the dew point very fast, so condensation will start to happen. That also explains why water droplets will form on the grasses, the blades of the leaves, okay, in the early morning. Okay, next is this term called humidity ratio, which is not a very commonly used term in weather station, for example. Alright, so the other more commonly used humidity is called relative humidity, but now we are going to talk about this term called humidity ratio. So what is humidity ratio? It means the amount of water vapor inside 1 kg of dry air. So for example, an air-conditioned space is around maybe 14 grams per kg. So that means 1 kg of dry air in an air-conditioned space, usually the amount of water vapor is around 14 grams. So if you look over here, okay, there's this thing called a desiccant. So what does the desiccant do? And usually where do you find these packets of desiccant? You will usually see it in a packaging. For example, new shoes, new bags, or your dried foods. These are the places you may find this silica gel or desiccant. and you may also purchase this type of desiccant to put it in your wardrobe, in your cupboard. So the purpose of all this is to absorb moisture to reduce the humidity ratio in the space itself. So because there's a chemical inside that is able to absorb moisture from the air and contain it inside the container itself. Okay, the next term, relative humidity, is something that is more commonly seen maybe in a weather forecast station. So this RH is usually given in percentage. So for example, they may say the weather today is 28 degrees Celsius and 80% RH. So what do we mean by RH, and what's the difference between RH and humidity ratio? So I like to use an example. Let's say you have a container, and this container is 1 liter. Okay, the capacity of this container is 1 liter. And right now, let's say you filled it up to maybe around 600 ml. Okay, 600 ml of water. Okay, so the question is, how many percent of the container is filled? Okay, so percentage filled, we can do a very quick calculation. It's very simple. It's just 600 ml divided by 1 liter. So it's 60% filled. Okay, why am I using this illustration? Very simple, because each of these properties represent one of the air properties. So the container size is equivalent to your dry bulb temperature. The amount of water inside the container is equivalent to your humidity ratio. So humidity ratio, just now I forgot to mention, the symbol is actually omega. It's not really W, okay, it's omega. And finally, the percentage filled in the container is as good as the relative humidity. Okay, so now using this simple illustration, and if I want to increase the RH in the room, let's say the current RH in the room is 60%, and I want to increase it to maybe 70%, what can I do? So there are two ways to achieve that. There are two methods. The first one that is more obvious is to add moisture into the air by using maybe a humidifier. And what does a humidifier do? It will spray very fine mist of water into the air itself, such that they get evaporated and is contained inside the air. So you can use a humidifier, or you start to spray water, fine water onto the into the air itself. So that is a very obvious method, that is to add moisture to the air, and the RH will increase accordingly. The second method to increase the RH, but by not doing anything to the moisture content, is to reduce the container size. So reduce the container size, the percentage filled will increase. For example, if my container size is downsized until 800 ml, and now it is, so this is 800 ml, and the amount of water is still the same, that means you don't add any water inside, the percentage filled becomes 75% automatically. That is to say, if we reduce the dry bulb temperature of the air, the RH will increase accordingly. Alright, so let's bring it one more step further. Okay, if I reduce the container size until it is the same size as the amount of water inside, what will happen? So at this point of time, your RH is 100%, and at this particular temperature, remember that I mentioned that the container size is your temperature. This temperature is as good as your dew point temperature. So remember just now when we talk about dew point, we say that if the temperature is at the dew point, is at 100% RH. So any temperature below the dew point, let's say you downsize the container until it becomes 500 ml. Alright, so what will happen? You can only contain 500 ml of water. The rest of the water will have to flow out as condensate. So that is when condensation will take place. when the temperature is below the dew point. So I hope this illustration will clarify your doubts about what is dew point temperature, RH, and the relationship between dry bulb and humidity ratio, how it affects RH. Okay, the next property, air properties, is specific volume. So whenever you see the word specific, okay, whenever you see a word specific in front of a parameter, all right, it means per unit mass, all right. Like specific enthalpy is energy per unit mass, specific volume is volume per unit mass. So the units is meter cube per kg, all right. So meter cube per kg may not be a common unit that we see, okay, or we use, but if you inverse this, okay, if you inverse this and it become kg per meter cube, it is now it become an unit that we use often. Kg per meter cube is your density units, okay. So that is to say, specific volume is the inverse of density. The higher is your specific volume, the lower is the density. So the bigger is your specific volume means is less dense, which means the air is lighter. And the last property is specific enthalpy. Specific enthalpy refers to the energy content in the air itself. So the amount of energy contained in the air is made out of two parts. It includes the sensible heat, which we roughly talk about in the very first second slide on dry bulb temperature, and the other one is called latent heat. All right, so these two heat content, and you divide by the mass of the air. That's why there's a word specific over there, specific enthalpy. So if you divide by the mass, then it will give you the change in enthalpy. Why is there a delta? Why is there a change in? Because it means that you have to do something to the air. For example, you heat up the air, or you cool down the air, or you humidify the air, the enthalpy value will change. Okay, so the absolute value of the enthalpy may not be so meaningful, but the delta, the change in enthalpy, will tell you something about the air processes that it has undergone. So what is the difference between sensible and latent heat? So sensible heat, as we mentioned previously, it refers to heat that will cause a change in temperature of the air. For example, when you go into an air-conditioned room and you start to switch on all the equipment, you start to switch on the lighting, and people start to occupy the space. So every single equipment or human will start to generate heat, and this heat will be absorbed by the air, so the temperature will start to increase slowly. Let's say you are not using an air conditioner to reduce the temperature. You just let it get heated up naturally. Temperature will start to increase naturally. All right, and the next one is called latent heat. Latent heat is the amount of energy change due to change in moisture content. So this is something that is not so obvious, but whenever you add moisture into the air, you are actually creating a heat load. So the highest contributor of latent heat is actually human itself, all the occupants, because every one of us will start to breathe in and breathe out water vapor, and the amount of water vapor that we breathe out is much higher than the amount of water vapor that we breathed in. So when 5%, 10%, or 50% start to occupy a room, the amount of latent heat will get higher and higher and higher. So the humidity ratio will start to increase, and this causes an increase in latent heat. So with that, I've completed this section. Thank you.